Hello students, today we'll discuss the assignment number 1 on set theory. So here your first question is that write the set of all vowels in the English alphabet which precedes Q. Means you have to write all the vowels which comes before your alphabet Q. So let's say that set is A and that set contains what? That set contains A, E, I and O. Okay, these are the vowels which comes before your alphabet Q. Now next question is, so now list all the elements of the set A X such that X is what? X is a month of a year not having 31 days. Okay, you have to collect all the months in which you do not have 31 days. So let's say your set A, this is what this is. In January, you know you have 31 days. So start with the Feb. So February. Now April. Yes. May, June, then June. Now September. Okay. Now November. So these are the month in which you have number of days less than 31. Okay. So this is your set A. Now let's move to the next question. Next question is, list all the elements of the set A. X is what? X is letter of the word Mississippi. So A is what? A is collection of M. Now next is what? Next letter is I. Next is what? That is S. Now next one is S. Now we already have S here. Okay. So you cannot repeat your element in your set. So M, I, S, and then the next letter is what? That is P. So these are what? These are the letters in the word Mississippi. Yes, M, I, S and P. You cannot repeat your same object in your set. Okay, take care of that thing. Now let's move to the next one. Next question is, are the following pair of sets equal? We know two sets are equal when they have exactly same elements. So give a proper reason for that. So if you observe A set, so A set is what? A set is solution of this equation. Yes, solution of this equation. So when you solve this equation, you will get what? X square plus 5x plus 6 is equal to 0. And you know, you can find the linear factor for this quadratic, x plus 2 and x plus 3. That thing is 0. So from here you can say x is either minus 2 or minus 3. So it means your set A contains minus 2 and minus 3. These two elements. Yes. And set B is what? Set B is equal to 2 and 3. So are they equal? No. Here you have 2, but in set A you have minus 2. So they do not have exactly same elements. So A and B are not equal set. So A is not equal to your B set. So this is the final answer. Okay. Now let's move to the next one. Next question is, show that the set of letters needed to spell cataract and the letter needed to spell tract are equal. So if you observe in this, you required letters. These are C, A, T and R. Yes, these are the letters to require to make your word cataract. C, A, T, A, R, A, C, T. Yes, C, A, T and R. You cannot repeat your element in your set. Yes, similarly for these letters required, these are T, R, A and C. Okay, so for both the words we required CATR and here we required CATR. So it means these two sets contain exactly same elements. Yes, so we can say yes, the set of letters required to spell cataract and tract are equal. Yes, so from here if you assume this is set A, assume this is some set B, so we can say A is equal to B. Got it? So this is your final answer. Now next one is, you have to write the set builder form for this set. So we have to observe the behavior of our elements here. So first is what? 1 by 2. Yes. Second is what? Second is 2 by 5. So in the numerator, if we take 1 by 2, so we can say this is 1 by 2 can be written as 1 upon 1 square plus 1. Yes, 2 by 5. So you can observe this thing is what? This is 2 by 2 square plus 1. Got it? 3 by 10. This is what? This is 3 divided by 3 square plus 1. And similarly for the other elements. Yes, for 4 by 17. For 4 by 17 we can say 4 divided by 4 square plus 1. 5 by 26. Next one is 5 by 26, which can be written as 5 by 5 square plus 1. Similarly for 6 by 36. 6 by 37, sorry, that is 6 by 6 square plus 1. And the next one is what? 7 by 50. So this is 7 by 7 square plus 1. So now you can find the behavior of your elements. Let's say this set is what? This set is set A, and this set contains element of the type n upon n square plus 1. Yes, this is the behavior of your elements, n upon n square plus 1, where n is what? N is a natural number. Yes, n is what? N is a natural number, and we have restriction that n is less than or equal to what? Less than or equal to 7. So this is what? This is the set builder form for your particular set. Got it? Now let's move to the next one. Next is what? We have to find that which one is empty set or which one is not an empty set. So if you observe the first one, so first set is what? Think about it. X is collection of all the real numbers such that 0 to 1. Yes, so obviously 0.5. Yes, if you take 0.5, that is in this interval 0 to 1. 0.5 is a real number, and this belongs to where? This belongs to your set A. Yes, so it means we have some element. So A cannot be empty set. So A is non-empty. So first one is what? First one is non-empty set. That is non-empty. Okay, this is non-empty. Got it? Now for the next one. X such that x belongs to rational. Q stands for your rational numbers, and x square minus 2 is equal to 0. So when you simplify this equation, x square minus 2 is equal to 0. So from here you can say x is equal to what? X is equal to plus minus root 2. Yes, but x is equal to plus minus root 2. That is not a rational number. This is what? That is an irrational number. Yes, root 2 and minus root 2 both are what? Both are irrational number. So it means there does not exist any rational for which x square minus 2 is 0. So it means there does not exist any element in this set. So this is empty set. Okay, second one is what? Second one is your empty set. Got it? Now for the next one. X is what? X is collection of all the natural numbers. C is what? C is set of all the natural numbers such that which is less than 8 and greater than 12. So this is impossible. You cannot find any natural number which is smaller than 8 but greater than 12. So this is what? This is again an empty set. Okay, this is again an empty set. Now for the next one. D is what? D is collection of all the points common to any two parallel lines. Let's say this is your line L1. Let's say this is L1, and you have some another line. Let's say that is L2. So how many points you have which is common in L1 and L2? So nothing. Yes, yes or no? So there does not exist any point here which is common in L1 and L2. If L1 here, we are assuming that L1 is what? L1 is parallel to L2. So nothing is common. No point is common in L1 and L2. So it means this is what? This is again an empty set. Okay. So it means D is empty set. Got it? So now let's move to the next one. Now first question is, before that, which of the following sets are finite or infinite set? Now you have to find that your set is finite or infinite. Finite means if your set contains finite number of elements, so it is finite. If it contains infinitely many elements, then you can see your set is an infinite set. So first is x is natural number and less than 200. So if x is a natural number and less than 200, so you can say this set is what? Natural number. So started with 1, 2, 3, 4 until less than 200, so 199. So how many elements we have? Sir, we have finite elements. We have 199 elements here. Yes, so this is what? This is a finite set. Finite set. Got it? Next one is x belongs to z, means an integer, and x square minus 2 is equal to 0. So if x square minus 2 is equal to 0, we already know x square minus 2 is 0 means x is equal to plus minus root 2, and this is what, this is not an integer, so it means this is an empty set. An empty set contains how many elements? 0, and 0 is a finite number, so this means this is also a finite set. Yes, x belongs to z and x square minus 2 is equal to 0. It's not possible because x square is 2 whenever x is plus minus root 2, and this is not an integer, so it means this is an empty set. An empty set is what? That's a finite set. Next one, sir, x such that x is a rational number and lies between these two real numbers. So we know between two numbers how many irrational numbers we have. So between two distinct real number, we have infinitely many rational numbers. We know this property. So it means this is what? This is an infinite set. Yes, infinite set. Got it? Next thing, x is what? X is a point on a line. Okay. For the fourth one, let's say this is your line. This is your line. Okay. In this direction and similarly in this one. Okay, this is your line. So how many points you have? Sir, we have infinitely many points. Yes or no? This point, this point, this point, this point. So how many points you have? Sir, infinitely many points on this line. So this is what? This is again an infinite set. Okay, this is also an infinite set. Got it? Now let's move to the next one. Next is sir, you have a set A 1 2 3 4 5 6 and you have to insert the appropriate symbol. This is what? This is belongs to. We already know that is what? That is belongs to. Okay, and this is does not belong to. Okay, does not belong to. Got it? So here if you observe, 5 is what? 5 is member of your set. So you can say 5 belongs to the set A. 5 belongs to your set A. Got it? Similarly, if you observe 8 is not the member of your set, so you can say 8 is not the member of your set A. Got it? 0 is not the member of your set A, not the member. 4 is what? 4 belongs to your set A, so 4 belongs to set A. 2 is what? 2 belongs to set A, and 10 is not the member, so you can say 10 does not belong to the set A. Got it? So this is the answer. Now next one is, okay, match each of the set on the left and the roster form. This is what? This is your roster form with the same set on the right described in the set builder form, and this is what? This is the set builder form. So if you observe the first one, okay, first one. So for the first one, x is such that x plus 5 is 5 and x belongs to integer. So if x plus 5 is equal to 5, so after the simplification we can say x is equal to 0, and we know x is equal to 0 is what? That's an integer. Yes, so it means A set is what? A set is singleton 0, so it means 3 is connected with A. Okay, 3 is connected with A. Next thing, x is a prime divisor of 10. We know prime divisor of 10 are 2. 2 is the divisor of your 10, and then 5 is also what? 5 is also the prime number and divisor of your 10. Next divisor is 10, that is not a prime number, and the first divisor, that is 1, that's also not a prime number. So x is a prime divisor of 10, so it means x can take two values, either 2 or 5. So 2 or 5, it means the sixth one is connected with B. Yes, 6 is connected with B. Next, x is letter of the word Rajasthan. So what is this set? This set contains R, AJ, yes, S, T, and H, and N. Yes, so these are the letters in your word Rajasthan. So you can connect with A, H, J, R, S, T, and N. Yes, these 7 alphabets here, 7 alphabets are here, and these are the same alphabets here. Yes, so you can say fifth one is connected with the C. Okay, fifth is connected with the C. Next thing, 1, 2, 5, 10. And here you have x is divisor of 10, and divisor of 10 are what? Divisor of 10 are 1, 2, 5 and 10. These are the divisor of your number 10. So you can say fourth one is connected with D. Got it? Next. Next is what? X such that x square minus 25 is equal to 0. So x square minus 25 is equal to 0. It means what? It means x is equal to plus minus 5. X is equal to plus minus 5. So plus minus 5 is here. Second. So second is connected with E. Second is connected with E. Yes. And last one is what? X is letter of the word apple. So letter of the word apple is A, P, L and E. Okay. A, P, L and E. That is 1. So 1 is connected with the F. Got it? So final answer is what? Final answer is, so 1 is connected with 1, that is APLE, that is connected with F. Second, that is 5 comma minus 5, solution of this, so connected with E. Third is what? 0, that is connected with A. Okay, next one is fourth. Fourth is what? Fourth is 1, 2, 5 and 10, divisor of 10, that is connected with D. Fifth is AHJRSTN, this is letter of the word Rajasthan, so connected with C. And sixth is what? Sixth is 2 and 5, prime divisor of your 10, that is connected with B. So sixth is connected with B. So this is your final answer. Okay, this is the final answer. Now let's move to the next one. Now we have multiple choice question, single correct. Okay. So you are given with finite set contains, means fill in the blanks, finite set something, empty set. Okay. So first option is it's same as empty set. No, that's not true. Yes, why? Because if you take A is equal to 2, this is what? This is finite, but this is not an empty set. So this is same as empty. That's not the correct one. Is an empty set? No. Finite set may or may not be an empty set. So that's the thing. Yes, finite set may or may not be an empty set. Yes, so is not an empty set? No. Finite set may be empty set. So your final answer is here, that is D. Your finite set may or may not an empty set. Got it? Now next one. Next is, let A be the set of prime numbers less than 6. So A is set of prime number less than 6. So 2 is the prime number, 3 is the prime number, 5 is the prime number less than 6. And be the set of prime factors of 30. So factors of 30 are, factors of 30, this is your number, and here write the factors. Factors of 30 are 1, 2, 3, yes, then 5, then 6, then 10, 15 and 30. Okay, these are what? These are the factors. Yes, these are the factors. B is what? B is set of prime factors of 30. Prime factors of 30 are what? This is not the prime number, this is not the prime number, this is not prime, this is not prime, this is not prime. So prime numbers are what? 2, 3 and 5. Okay. Now set A and B are what? Set A and B are, you can observe that these are equal sets. Yes, contain exactly same elements. So you can say these are equal sets. Yes, A and B are equal. Next one. Next is what? A is equal to 1, 10, 15 and 17 and B is equal to 1, 5, 7 and 8. Then which of the following is correct statement about both A and B? So A and B are equal? No. A and B are empty? No. A and B are infinite set? No. Now what about equivalent? We know two sets are equivalent if they have same number of elements. Yes, for finite sets you can say two sets are equivalent if they have same number of elements. So if you observe the cardinality of your A set, this is what? This is 4. Yes, 1, 2, 3 and 4, you have 4 elements. Similarly, if you observe the cardinality of your set B, that contains 1, 2, 3 and 4 elements. Yes, so both the sets having the same number of elements, so you can say A and B are what? They are equivalent sets. So B is the correct one. Okay. Next question is, which of the following is an infinite set? Which of the following is an infinite set? Okay, infinite set. Set of days of week. So obviously this is not an infinite, having finite number of elements. Set of months in a year, finite number of elements. Yes. Set of prime numbers less than 99. Obviously prime numbers are which are less than 99. We have finite number of prime numbers before 99. Yes. So this is not a finite set. So we have to find infinite. Set of points on a line. We already observed that thing, that set of points on a line is what? That is an infinite set. So B is the correct one. Got it? Now let's do the next one. Solution. Which of the following sets are equal? So X we already know here, that is 1 and minus 1. Y is what? Y is equal to minus 1 and 1. Got it? And Z is what? Z is, sir, X is root of this equation and X is an integer. Okay, X belongs to Z. Z means set of integers. So X square minus 1 is 0. X square minus 1 is equal to 0. It means X minus 1. X plus 1 is equal to 0. Using the property A square minus B square is equal to A minus B into A plus B. Okay, A square minus B square, you can write 1 as 1 square. So A minus B, A plus B. Okay, so from here you can conclude either X is equal to 1 or minus 1. So you can say, and 1 and minus 1 both are integers. So Z is what? Z is minus 1 and 1. Okay, if you observe X, Y and Z, all these three sets contains exactly same elements. So you can say all the three sets are equal. So question is, which of the following sets are equal? So X, Y and Z. So D is the correct one. Got it? Next one. Now this is your revision section, in which we have some questions from your 10th class. Okay, 10th or 9th basically. So solution. PQ are respectively the midpoints of side BC, CA and AB. So it means we have a triangle ABC first of all. So if we have a triangle ABC, so let's draw your triangle. This is your triangle A, B and C. Got it? PQ are respectively the midpoints of side BC. These are the midpoints. So midpoint of BC is P, BC is P, CA is Q, midpoint of CA is Q, and midpoint of AB is R. So let's say that is midpoint of AB, this is R. Okay, PR and BQ meet at X. PR, so PR is this one, PR and BQ. So BQ, first of all, this is your BQ, this is your PR. They meet at some point. Let's say that point is what? That is X. Okay, now next one is CR and PQ. CR and PQ. CR, so this line, CR and PQ and PQ, they meet at some point Y. They meet at some point Y. Okay, we have to prove that this XY is equal to 1 by 4 times BC. XY is what? XY is this one. XY. This is your XY. Yes. This XY is equal to what? This is 1 by 4 times this BC. You have to prove this thing. So now join R and Q. Okay. So first step is what? First step is solution. In solution, construction, you can say construction is what? Join R, Q. Yes, join R, Q. Got it? Now, proof is what? Proof or solution, you can say here. This is what? We know one theorem, that is midpoint theorem. Midpoint theorem says if you join the midpoints of two sides of a triangle, then the side is what? The resulting line segment is parallel to the third one and half of that third side. So from here, if you observe, sir, P is midpoint, R is midpoint of AB, P is midpoint of BC. So we can say PR PR is parallel to, this PR is parallel to AC, okay, and PR is equal to half of AC because of midpoint theorem. Yes. Similarly, P is midpoint of BC, Q is midpoint of AC, so we can say PQ is what? PQ is parallel to AB, and this PQ is half of AB. Got it? Because of same reason, midpoint theorem. Next is about RQ. So RQ is what? RQ is parallel to BC, and RQ is half times of BC. Got it? So these are the three informations from your midpoint theorem. Okay, now observe some situations. So sir, from here we know PP, yes, BC is parallel to RQ, so we can say this PB is parallel to RQ, and PQ is what? PQ is parallel to AB, so we can say PQ is parallel to BR. Yes. Okay. Now, so now we can say PQ parallel to, PQ is what? Parallel to BR, and BP, that BP is parallel to what? RQ. Yes. Yes or no? So it means your quadrilateral BPQR is a parallelogram. Yes, this is parallelogram because of the definition of your parallelogram. Okay, now sir, this is what? BQ is what? BQ is the diagonal. PR is what? PR is what? Diagonal of your parallelogram. And X is what? X is point of intersection of your diagonal. So you can say this X is midpoint of your BQ. Yes, because we know diagonal bisects each other. Got it? Diagonal bisects each other. So we can say X is midpoint of BQ. Yes. Why X is the midpoint of BQ? We know that point of intersection of diagonal bisects each other. Yes, you can write here point of intersection of diagonals of parallelogram bisects. Yes, point of intersection of diagonals bisect your diagonals. Yes, so X is what? X is midpoint of BQ. Now, in the similar manner, we can say PC is parallel to RQ. Yes. Similarly, we can say, you can write here this information that, or let's use the next one. Okay, let's use the next one. So here we have information that PC is parallel to RQ. PC is parallel to RQ. PC is parallel to RQ, and CQ is parallel to PR. CQ is parallel to PR. Yes, CQ is parallel to PR. So you can say CQRP is a parallelogram. This is what? This is a parallelogram. Again, if this is a parallelogram, so Y is what? Y is the midpoint of this diagonal and this diagonal PQ. Yes, because Y is point of intersection of diagonal, so this diagonal bisects each other, we know. So Y is what? Y is the midpoint of your PQ. Yes. So Y is what? Y is midpoint of PQ. Y is midpoint of PQ. Yes. Because Y is what? Y is point of intersection of diagonals. Okay, and PQ is your diagonal for CQ, RP. So that's why Y is what? Y is the midpoint of your PQ. Okay, now observe this triangle. PRQ. X is midpoint of PR. Yes. X is obviously the midpoint of BQ and PR also. Yes, and PR. Got it? Because again, X is what? X is point of intersection of diagonals. So X is midpoint of PR. Similarly, Y is midpoint of PQ and CR. PQ and CR, you can say. PQ and CR. Okay, now in this triangle RPQ, X is midpoint of RP. Yes, Y is midpoint of PQ. So let's draw your triangle here. This is P, this is R, this is Q. Here you have X, here you have Y, and these are what? These are the midpoints. So when you join your XY, so according to the midpoint theorem, so XY is equal to half of RQ. XY is equal to half of RQ. And we know, because of again midpoint theorem, yes, and we know XY is equal to RQ, and RQ is what? Half of BC. Half of BC. So you can say this is half times RQ is half of BC. So this is 1 by 4 times BC. So XY is equal to what? XY is equal to 1 by 4 times BC. So this is what? This is my answer. Okay, or this is, you can say, proof. Okay, hence proved. Got it? So here we are using midpoint theorem and 3 times midpoint theorem and properties of parallelogram. Okay, so now let's move to the next one. Next is what? Next is, sir, P is point of the side AB of parallelogram ABCD. Midpoint of side AB. Okay, so first of all, let's draw your parallelogram. Let's say this is your parallelogram. This is your parallelogram A, B, C, and D. This is the parallelogram. Okay, ABCD is parallelogram and P is the midpoint of AB. So let's say P is somewhere here. This is the midpoint of AB. Okay. Now a line through B parallel to PD. So first of all, join your PD. If you draw a line which is parallel to PD, this is not parallel. So if you draw a line which is parallel to PD, yes, let's say this is parallel to PD from B, yes, a line through B parallel to PD meet DC at some point Q. Let's say that point is Q. Okay, and AD produced at R. So when you produce your AD, so intersect this thing at R. Okay, now prove that AR is equal to 2 times BC. Got it? Now, sir, if you observe this triangle ARB, in triangle ARB, okay, ARB, P is the midpoint. ARB is this triangle, yes, this triangle. P is the midpoint, and this line PD is parallel to this third side. Yes, line PD is parallel to the third side. So according to the converse of midpoint theorem, you can say D is the midpoint of, we can say D is the, or before that you can write in triangle ARB, P is what? P is midpoint. P is midpoint of AB. P is midpoint of AB and PD is parallel. PD is parallel to BR. From here, you can say what? We can say this is midpoint and this is parallel to the third side. So D is what? D is the midpoint of AR. Okay, AR. Because of what? Because of converse of midpoint theorem. Okay, converse of midpoint theorem. Now, if D is midpoint of AR, so from here you can say AR is equal to what? AR is equal to AD plus DR. AD plus DR. And D is what? D is the midpoint. So D is midpoint, then AD is equal to DR. Yes. And AD is equal to DR. So you can say AD plus DR is AD. So this is 2 times AD. Yes, 2 times AD. And this is parallelogram. So we can say opposite sides are equal. So AD is equal to what? AD is equal to BC. So this is 2 times BC. So now AR is what? 2 times BC. So this is the proof. So you can say hence proved. Got it? Hence proved. Now let's move to the next one. Next is question number 18. That is, show that the quadrilateral formed by joining the midpoints of the consecutive side of rectangle. Okay, first of all you have rectangle. So let's say this is your rectangle. Rectangle A, B, C and D. Okay. Now, show that the quadrilateral formed by joining the midpoints of the consecutive side of rectangle is a rhombus. So, if you take midpoints, so let's say midpoint of AB is, let's say, P, midpoint of this thing is Q, midpoint of, let's say, this is R, and midpoint of this one is, let's say, S. So, when you join the midpoints, okay, when you join the midpoints, so this quadrilateral which is formed by joining these midpoints is what? This is a rhombus. You have to prove this thing. Okay. So now construction is what? Let's join AC. Okay. If you join AC, let's say this is the joining of AC. Okay. Now in triangle ABC, in triangle A, B and C. Okay. A, B and C. P and Q are the midpoints. Yes. In triangle A, B and C, P, Q are the midpoints of side. P and Q are midpoints of sides AB and BC respectively. AB and BC respectively. Okay. So it means what? According to the midpoint theorem, in triangle A, B, C, PQ are the midpoints. So according to midpoint theorem, PQ is parallel to AC. PQ parallel to AC and PQ is parallel to AC and PQ is half times AC. Okay. Yes. In the similar manner, if you observe ADC triangle, in triangle ADC, yes, in triangle ADC, R and S are what? R and S are midpoints of your sides. So it means RS is, you can say similarly, RS are the midpoints of your CD and AD respectively. So you can say RS is parallel to AC, RS is parallel to AC and RS is half of AC. Yes, RS is half of AC. So using this, let's say this is your first and let's say this is the second one. So you can say what? You can say PQ parallel to AC, RS is parallel to AC. So from these two, we can say PQ is parallel to RS. RS is parallel to PQ and PQ is half of AC, RS is half of AC. So you can say PQ is equal to RS. Yes. So PQ is equal to RS. PQ is parallel to RS. Yes. PQ is parallel to SR or RS, or similarly PQ is equal to RS. So in a quadrilateral, if one pair of sides are parallel and equal, then you can see your quadrilateral is a parallelogram. So here we can say PQRS is a parallelogram. Yes, you have a theorem in which we know that if one pair of opposite sides are parallel and equal in a quadrilateral, then that quadrilateral is a parallelogram. So according to that one, we can say PQRS is what? PQRS is a parallelogram. Okay. Now we have to prove that this is a rhombus. So a parallelogram is a rhombus if one pair means adjacent sides of your quadrilateral are equal. Yes. Now we have to prove what? We have to prove adjacent sides are equal in this quadrilateral. So let's take this one, this triangle APS. Okay. For this thing, let's take APS, this triangle. In triangle APS and BPQ, okay. In these two triangles, you can say AP is equal to PB. Why? Because P is the midpoint. AP is equal to PB. AP is equal to PB because P is midpoint. Okay. Next one. Next is angle A is equal to angle B because this is rectangle, so both are 90 degree. Yes, this is 90. This is 90. Got it? So you can say angle A is equal to angle B. Both are 90. Yes. Next one. Next one is what? AS is equal to BQ. AS is equal to BQ. Why? Because we know AD is equal to what? AD is equal to BC. Opposite sides of rectangle are equal. AS is what? So it means AD by 2 is equal to BC by 2 also. If AD is equal to BC, so AD by 2 is equal to BC by 2. And AS is what? AD by 2 because S is the midpoint. So you can say AS is equal to BC by 2 is what? BQ because Q is the midpoint. So this is BQ. So you can say AS is equal to BQ because of this. Yes. Because of this you can say AS is equal to BQ. AS is equal to BQ. Got it? So if these things are equal, AS is equal to BQ, angle is 90, AP is equal to PB. So your triangle APS and BPQ are congruent. Okay, so from here you can say triangle APS congruent with triangle BPQ. Okay, BPQ. Now sir, so it means PS is equal to PQ. Yes, from here you can say PS is equal to PQ. PS is equal to PQ. Why? Because of CPCT property. Corresponding part of congruent triangles are equal. Okay, so now let's say this is your third one, and let's say PQRS is a parallelogram. PQRS is a parallelogram, and PQ is equal to PS. Yes, now we know PQ is equal to PS. So it means PQRS is a rhombus. Okay, PQRS is what? PQRS is a rhombus. PQRS is a rhombus. Got it? So this is equal to PS. We know PQ is equal to SR and PS is equal to QR. So all the sides are equal. So it means this is what? This is a rhombus. Got it? So this is the solution. Now move to the next one. Next question is this. Question says in a triangle ABCD, let's draw a triangle ABCD. Let's draw a triangle ABC. This is A, this is B, this is C. AD is the median through A. AD is the median through A. Median means divides your opposite side in two equal parts. E is the midpoint of AD. Let's say E is midpoint of AD. E is the midpoint. Now BE produced meet AC in F. BE produced and meet AC at F. Okay, now we have to prove that AF is equal to 1 by 3 times AC. So how can you prove? Sir, construction, we need some construction here. That construction is what? Draw a line. Let's say that point is G. Construction is draw a line segment, DG parallel to BF. DG parallel to BF. Okay. So draw a line segment DG, where G is what? G is the point of intersection of this line and AC. Yes. Draw a line segment DG which is parallel to this BF. Got it? Okay. Now prove. So sir, here in triangle this ADC, in triangle AD and C, in triangle AD and C, okay, in ADG, not C, let's take ADG, okay, ADG, in triangle AD and G, okay, AD and G, in this triangle, in triangle ADG, sir, E is what? E is midpoint of AD. E is the midpoint of AD. This is given to us that E is the midpoint. And EF, if BF is parallel to DG, so EF is also parallel to DG, and EF is parallel to DG. Yes, EF is what? Parallel to DG. So E is midpoint, EF is parallel to DG. So converse of midpoint theorem says F is midpoint of AG. Yes. So from here you can say F is midpoint of AG. Yes. So it means what? AF is equal to FG. It means AF is equal to FG. Okay. Why F is midpoint? Because of converse midpoint theorem. Yes. Now let's do this one. In triangle BFC, okay, in triangle BFC, in triangle BFC, okay, BFC, got it. Now D is midpoint of BC, D is midpoint of BC, and D is midpoint of BC and DG is parallel to BF. DG is parallel to BF. Yes, D is midpoint of this BC and DG is parallel to BF. So in triangle BFC, using your converse midpoint theorem, you can say G is midpoint of FC. Okay, from here you can say G is midpoint of FC because of converse midpoint theorem. Yes, parallel, DG is parallel to BF and D is midpoint of BC, so G must be the midpoint of your FC. Yes, G is midpoint of FC. So from here you can say FG is equal to GC. Okay. Now sir, you can write AC is equal to, now AC is equal to AF plus FG plus GC. Yes, AF plus FG plus GC. Got it? AF plus FG plus GC. So AF as it is plus FG is what? FG is equal to GC. Yes, so you can say GC plus GC. Okay. Now AF or GC can be written as FG. Sorry. So this is FG plus GC is equal to what? GC is equal to FG. Now AF is equal to AF as it is plus FG is what now? FG. FG is equal to AF. FG is equal to AF plus AF. So that is 3 times AF. Okay, so from here you can say AF is equal to what? 1 by 3 times AC. Okay, AF is equal to 1 by 3 times AC. This is your question. So hence proved. Okay, you have to prove that AF is equal to 1 by 3 AC. AF is equal to 1 by 3 AC. That's your answer. Got it? Now let's move to the next one. And this is your last question of the first assignment. Question is ABCD is a parallelogram. Okay, sir. So first of all, draw your parallelogram. So let's say this is the parallelogram A, B, C and D. Okay, ABCD is a parallelogram. E and F are the midpoints of AB and CD. Midpoints. So let's say E is the midpoint of AB and F is the midpoint of CD. F is the midpoint of CD. Okay, so F is somewhere here, let's say. Next, GH is any line intersect ADEF. So EF means you have to join E and F. So let's say that's your line EF. Now we have line some GH is any line intersect AD at G, EF at P and BC at H. Okay, so let's say this is your line. So this is G, this is P and this is H. GP and H. Okay. Respectively, GH is any line intersect AD at G, EF at P and BC at H. Now prove that GP is equal to PH. You have to prove that GP is equal to this PH. Okay, that's the question. So first of all, let's say here E and F are the midpoints. So we know that AB is equal to, we know AB is equal to CD because in parallelogram opposite sides are equal. Next thing is, and E and F are the midpoint, so you can say AB by 2 is equal to CD by 2. Yes, so AB by 2 we can say AB by 2, that is BE, which is equal to CD by 2 is CF. Yes, because E and F are the midpoints of AB and CD respectively. So we can say BE is equal to CF. B is equal to CF. And B is parallel to CF also. B is parallel to CF. Yes, because AB is parallel to CD. So B is parallel to CF. So from these information, we can say BCFE is a parallelogram. Is a parallelogram. Okay, BCEF is a parallelogram because one pair of opposite sides are equal and parallel. So this quadrilateral is a parallelogram. Similarly, we can say AE is what? Half of AB. Yes, and DF is what? DF is half of CD, and AE is parallel to DF. So similarly we can say ADFE. This is a parallelogram. Okay. Similarly, we can say ADFE is parallelogram. Why? Because A is what? Half of AB and DF is what? Half of CD. and half of AB and half of CD is equal. So A is equal to FD. You can write here A is equal to FD. Yes, A is equal to FD and A is parallel to FD. And A is parallel to FD because AB is parallel to CD in the parallelogram. So this is what? This is one pair of opposite sides are equal and parallel. So it means your quadrilateral is a parallelogram. So now you know these are the parallelograms. So from the first one you can say BC is parallel to EF. Yes, BC is parallel to EF. Okay. BC is now. Now we can say BC is parallel to EF. Yes, BC is parallel to EF. And AD is parallel to EF. Okay. And AD is parallel to EF because BCEF and ADEF are the parallelograms. So from here you can say if BC is parallel to EF, AD parallel to EF, so all the three lines are parallel to each other. So you can say BC is parallel to EF and EF is parallel to AD. So all the three lines are parallel to each other. Got it? This is the information. Now let's say when we extend this line AB of your parallelogram and this GH, when you extend these two lines, they will intersect at some point. Yes, they will intersect at some point. Let's say that is Y. Okay. So when you extend your line AB, when you produce your line AB and when you produce your line GH, then they will intersect each other at some point. Let's say that point is some Y. Okay. Now, according to the basic proportionality theorem, BPT, you already know that theorem from your 10th class. Okay. So theorem says what? I'm telling you here. BPT is what? Basic proportionality theorem says if you have a triangle ABC and if you draw a line which is parallel to the third side and intersect your other two sides at two distinct points, okay, then your line intersect these two lines in the same proportion. Means what? Means what? Means this one. Let's say this is your triangle. Okay, I'm here giving you the idea of your BPT. So let's say if this is your triangle, okay, triangle A, B and C, and if you draw a line which is parallel to BC, which intersect the other two sides at two distinct points, let's say D and E. Okay, here we are given with the D is what? D is parallel to BC. Okay, if you have a triangle A, B, C and you draw a line which is parallel to the third side and intersect your two sides at two distinct points D and E, so D is parallel to BC, then AD upon DB is equal to AE upon EC. That is your BPT, basic proportionality theorem. Okay, we'll use this theorem here. First of all, in triangle YPE, okay, YPE, okay, in triangle YPE, AG is what? AG is parallel to P. Okay, so YA upon AE, so YA upon AE is equal to YG upon GP. Yes, YG upon GP. Got it? Similarly, in triangle YHB, in triangle YHB, okay, in triangle YHB, this P is what? P is parallel to BH. So it means YP upon PH is equal to YE upon EB. YE upon EB. Okay. Got it? Now here, if you add 1 on both sides, so you'll get 1 plus ya, okay? Or let's do this thing here. For this one, if you add 1 on both sides, 1 upon ya upon ae, so this is equal to 1 plus yg upon gp. So from here, you can say ae plus ya upon ae, which is equal to gp plus yg upon gp. Okay, so now ya plus a, that is ye upon ae is equal to gp plus yg, that is yp. Okay, that is yp upon gp. Okay, so now if you observe from here, we can say yp upon ye is equal to ph upon eb, and from here we can say yp upon ye, yes, yp upon ye is equal to gp upon ae. So let's say this is 2 and let's say this is 1. So yp upon ye is equal to gp upon ae here and ph upon eb here. So from first and 2 we can say, you can write from first and 2 we can say ph upon eb is equal to gp upon a. Now what about ae and eb? ae, this one, and eb, yes, sorry, ae and eb. Sir, e is the midpoint of ab, so we can say ae is equal to eb. Yes, ae is equal to eb, yes or no? Okay, so we can say e is the midpoint, so ae is equal to eb. Okay, because e is the midpoint of ab, so e is midpoint, so ae is equal to eb. So it means ae is equal to eb, we can cancel this one, so we'll get what? gp is equal to ph, and we want what? We want gp is equal to ph, and this is what? gp is equal to ph. So this is the proof, hence proved. Okay, so that's your last question. Okay everyone, thank you. We'll discuss the next assignment in your next video. Bye bye.